Good day to everyone. Today we from Group 10 Communication Principles would like to present about the amplitude, angle and radio modulation in order to help you guys to answer the mission 4 of the Ericsson Tech Traveler game. The objectives of our video is to discuss about the importance of modulation and the variety type of modulation techniques. We will also learn on how to increase the data rates by increasing its bits per baud. Lastly, we will talk about the advancement regarding communication technology that are happening all around the world. A very important parameter in data transmission are bit rate and baud rate. Bit rate is the number of bits can be sent per second. Baud rate is the number of signal changes per second. Baud rate is crucial for determining the speed and efficiency of data transmissions between devices. Next, what is modulation index? Modulation is an operation of varying amplitude, frequency or phase carrier signal accordingly with amplitude of modulating signal that's suitable with transmission medium. In addition, the modulating signal is known as information signal or message signal, and the signal produced from modulation process called modulated signal. Modulator is used to generate modulated signal, and demodulator is used to convert the modulated signal back to modulating signal at receiver. Modulation is important in terms of distance, multiplexing and interference or noise, as modulation allows long-distance communication. Many signal combined can be transmitted at one time, and noise in signal reduce. Let's discuss the 3 types of analog modulation and 3 types of digital modulation in this video. The 3 types of analog modulation are amplitude modulation, frequency modulation, while the 3 types of digital modulation are amplitude shift keying, frequency shift keying and phase shift keying. Now, let us go through the first type of analog modulation, which is amplitude modulation. Amplitude modulation is a process of sending carrier signal. After we have done modifying its amplitude based on amplitude of the information signal, it is important for us to remember the terms of information signal is the same as modulating signal. As shown in the block diagram, the modulating signal, which is information signal, is passed through the modulator and then combined with the carrier signal in order to generate a modulated signal. Next, frequency modulation. It is the process of sending carrier signal after modify its frequency based on amplitude of modulating signal. The frequency changes as amplitude changes. Last techniques of analog modulation is phase modulation. It refers to the process of sending carrier signal after modify its phase based on amplitude of modulating signal. The phase changes as amplitude changes. Let's move on to radio digital modulation. It is similar to analog modulation in case of varying carrier signal, but the modulating signal is digital signal. This is the block diagram for communication in digital channel and analog channel. Digital channel contains decoder and encoder, while analog channel contains modulator and demodulator. So first technique is amplitude shift keying. It refers to change amplitude carrier signal. When digital signal is high in terms of bit is logic 1, the output is amplitude of carrier signal. Otherwise, if digital signal is low in terms of bit is logic 0, the output is 0. It is also known as on-off keying. Next, frequency shift keying. It can be generated by generating 2 amplitude shift keying waveform whose contents are inverted with each other and adding them together with a summing amplifier. In this modulation, carrier has 2 frequencies. When modulating bit is logic 1, carrier with first frequency is transmitted. And when modulating bit is logic 0, carrier with second frequency is transmitted. Next technique is phase shift keying, the process of phase carrier change, and it is set to 0 degree or 180 degrees depending on modulating signal. If the modulating bit is logic 1, carrier phase changes. If the modulating bit is logic 0, carrier is a constant wave with no phase change. These are the advantages and drawbacks of 3 techniques that we have discussed. We moved on to the next key point, which is multi-level shift keying. Multi-level shift keying is a digital modulation technique where each symbol represents more than one bit. Where symbols means the final representation before transmitted through physical mediums such as amplitude. In other words, multi-level shift keying allows for multiple signal levels or states, and each level corresponds to a unique combination of bits. There are few examples of multi-level shift keying, which are binary phase shift keying, quadrature phase shift keying, 8-phase shift keying, and 16-phase shift keying. Next, we will be discussing about quadrature phase shift keying. QPSK is a form of phase shift keying in which two bits are modulated at once, selecting one of four possible carrier phase shift, which is 0 degree, 90 degree, 180 degree, and 270 degree. QPSK allows signals to carry twice as much information as the phase shift keying task, using the same bandwidth. QPSK is used for satellite transmission of MPEG-2 video, cable modems, video conferencing, cellular phone systems, and other forms of digital communication.
As shown in the diagram, the 00 represents 0 degree, 10 represents 180 degrees, 01 represents 90 degrees, and 11 represents 270 degrees.
As we have discussed earlier, bit rate is the number of bit that can be sent per second, while baud rate is the number of signal changes per second. The diagram on the left shows that the baud rate is 10 and the bit rate is 10 beat. This is because on every second, there will only be one bit of data that can be transmitted, while on the right diagram, the baud rate is 10 and the bit rate is 20. This is because for every 1 second, there will be 2 bits of data that are transmitted. Lastly, we discussed about the recent advancement in communication technology. First, 5G technology. The deployment of 5G networks has driven advancements in digital modulation technique. New modulation schemes, such as higher-order quadrature amplitude modulation QAR, are used to achieve higher data rates. Inter-satellite communication advancements. Innovations in satellite technology, including smaller and more powerful satellites, have improved global communication capabilities, especially in remote and underserved areas. Not least, next-generation Wi-Fi standards. New Wi-Fi standards, such as Wi-Fi 6, 802.11ax, bring improvements in data transfer speeds, capacity, and efficiency in wireless communication. There are many impact and benefits to the society, such as satisfy our basic needs as 5G delivers more data faster and more securely. Next, increase accessibility. People in remote and rural areas will be able to access services and resources that were previously unavailable to them. This will help to reduce the digital divide. Moreover, it enables to transform a wide range of applications from communications, entertainment, and education to healthcare, manufacturing, and transportation. The misconception on the topic in terms of privacy and security. Advanced communication technologies often involve extensive data collection, including user behaviors, preferences, and location data. This can lead to the creation of detailed user profiles, raising concerns about potential misuse or unauthorized access to sensitive information. And in terms of environmental impact, many communication technologies, especially data centers, mobile networks, and internet infrastructure, require significant amounts of energy. The increasing demand for data processing and transmission contributes to a rising carbon footprint. Thank you for watching patiently, and good luck for your mission.